Hi, in this new session, we will learn about deletion at end in singly linked list. So let's start. So here you are given a linked list of size 4. Your head is pointing to 2 node initially. Now here you want to delete node 5, which is the end of the linked list. So in the output you can see our node 5 is deleted and your head is pointing to 2, which was initially. So here you need to remember one thing, that if your size of linked list is greater than 2, then your head will never change. But suppose if your size of linked list is 1, like in this example, it is the start node and end node itself. So if you delete this node, your head will point to null. That is, here you can see that your head is changed. Now in this example, you can see that your linked list is empty. Then there is nothing to delete. So we are going to keep it as null only. Now I suggest try to write the basic implementation of deletion at end function, which take head as input argument and it's delete the node at end of the linked list, and after deletion it returns the new head. So now let's get the basic idea of deleted end function. Here you are given linked list of size 5 and you want to delete node 6. For this you need to traverse the linked list from head till node 5 and then change next of node 5 to be null. And since you are programming in C++, you need to deallocate memory for this node 6. So how do we do this? For this you can see that we need to stop at node 5. So we need to stop at node whose next of next is null. Again I am repeating, you need to stop at node whose next of next is null. So simply we run a loop that begins from head, and this loop stops when current next of next becomes null. And once we come out of the loop, we need to deallocate memory for this node 6 and then simply return the head. So let's see the basic implementation. So first we will point our current to head here. So we need to run a loop until current of next is not equals to null. So as you can see, our current of next is not equals to run. Till then we are doing current equals to current of next. Now once we come out of this loop, we will simply deallocate the current of next. That is, we will do delete of current of next. After deallocating, we will point current of next as null, and finally we will return the head. So this is the basic implementation. Now my question is this implementation completely correct? Are we missing any corner cases? Think for a while and then come back. We are doing current of next not equals to null. So we need to ensure that our link has at least 2 nodes in the linked list. Suppose there is a single node. We are accessing current next, which is null, and then we will simply doing null of next. So accessing null next will cause segmentation fault in C++. To avoid this, we need to handle 2 corner cases explicitly. So our first corner case will be, if linked list is empty, just simply return null. And our second corner case will be, if our linked list contains only single node. So what will we do in that case? If our head of next equals to null, that is, we are having only one node in our linked list, we will just delete that head node and we will return null. So you can see this is only the case when your head is changing, that is, your head is changing to null. Now I assume that you might get this implementation. So now let's run and check whether this code is working fine or not. So this is the code which we have just discussed. So let's run and check it. So here you can see that linked list before deletion was 2, 3, 4, 5, 6 and linked list after deletion at end is 2, 3, 4, 5. So this is matching our correct output. So I feel you might get the logic and the dry run now. If you face any kind of issue, just comment down below. We will try to answer as soon as possible. Thank you.